Hello students, welcome to another session of Most Important MCQs for your board examination for mathematics. Today we're going to discuss the topic of continuity and differentiability. We have already sent the link to everybody. Please forward it to all your friends and ask them to join immediately before it's too late. And those who have not subscribed to our channel, please subscribe to our channel immediately and get latest updates on all the live sessions and recorded videos of Brilliant Qatar. And continuity and differentiability, my dear students, this topic is very important for MCQs. And because it's not at all an easy topic for many of you to understand the concept of continuity and differentiability. More questions are going to be coming from continuity and differentiability part rather than the actual differentiation using formulas. So I've included more number of questions based on continuity and differentiability and very quick methods to how to get to the answer without even doing much of continuity and differentiation properties. Okay, now let's go forward to the questions, all of you. Question number 1 right away. Look at the question number 1. F of x is equal to minus modulus of x minus 1. Do not try to do too much to check the continuity and differentiability. Learn modulus functions. We know that a modulus function always have the shape of a V graph. And it's pretty clear that this is a continuous graph. So this function modulus is always continuous. Modulus is always continuous. Please learn, everybody, modulus graph is always continuous. Then what about the differentiability part of it? Just look at the modulus and tell me the value of x equal to 1, what happens to the function? The function becomes 0. Just understand what is the value of x which makes the function 0. Easy, right? X is equal to 1. Then the particular property of this value is the function f of x is not differentiable at x equal to 1. Very simple idea, very simple technique. The function is always continuous if it's modulus, and it's not differentiable at the value of x, which makes the function 0. Look at the options. Option A, wrong. Option B, not continuous, wrong. Option C says it's continuous but not differentiable at x equal to 1. It's a very simple technique. Don't use the continuity definition. Don't use the differentiability definition to analyze. Modulus function, my dear students. Yes, right answer already came from Fahad, Hafiz and Sana. So we're going to be taking the answer as option C. Option C, which says it's continuous but not differentiable at x equal to 1. Let's move forward to the second question now. A very similar question. It's about a function which is represented by f of x is equal to e raised to negative mod x. Here again you see a modulus, right? But along with modulus you see another function called e. Remember, e represents an exponential function. E represents what? An exponential function. And please learn the property of an exponential function is continuous and differentiable for all values of x. Exponential functions are continuous and differentiable for all values of x. But there's a small change in the question. Question talks about an exponential function along with a modulus. According to the property of modulus, it is continuous. Modulus part is continuous. But what about the differentiability of it? What about the differentiability, my dear students? You already know. How do you decide the differentiability of the modulus? Yes, you say it's not differentiable if x equal to 0. If I put the value of x as 0 in this modulus, the function itself becomes, modulus part becomes 0, right? The part where modulus becomes 0 is when x is equal to 0. So you're going to say continuous everywhere, yes, but not differentiable. Modulus is continuous, exponential is continuous. According to property, exponential and modulus both are continuous, but exponential is differentiable, but modulus is not differentiable when x is 0. We're going to look at option number A. Continuous everywhere, but not differentiable at x equal to 0. Very, very simple questions, highly expected for MCQ, a question with regard to modulus. So please be thorough with it. Right answer already coming from Fahad, Hafiz and Sana again. Others also, please try to give answers. The same concept is repeating. Okay, let's go for question number 3. What is the question about? It's about another function called a greatest integer function. I believe everybody knows what is a greatest integer function. A greatest integer function always breaks. A greatest integer function always breaks. Breaks where? Breaks when the value of x is an integer. Yes, the greatest integer graph always breaks when the value of x is an integer. So what should you understand from this? That this function is not continuous. Function f of x, greatest integer of x, is not continuous at the value of x which is an integer. If it's not continuous, we know the property of differentiability which says that a function which is not continuous is definitely not differentiable. The definition of differentiability, the common relation between differentiability and continuity is that if a function is not continuous, it can never become differentiable. So greatest integer is not differentiable as well. Is not differentiable at. So keep this idea in mind always. When x is an integer, it's not continuous. Similarly, when x is an integer, it's not differentiable. So what's the question here? This function denotes the greatest integer is continuous at. Option A, it's not continuous because 4 is an integer. Option B, it's not continuous because -2 is also an integer. Option C is also not correct because 1 is also an integer. But what about option D, my dear students? This is not an integer, hence it is continuous. So what's my answer? 1.5. Right answer, everybody. Very good. Fahad, Hafiz, Hadia, Sana and Faris. 1.5 is not an integer, so it's going to be continuous at 1.5. So please, very important to know it. Greatest integer functions are continuous and differentiable if the value of x is not an integer. Please keep in mind. Okay, so we have learned now 3 functions: modulus, exponential, greatest integer. Modulus, continuous everywhere but not differentiable at the value of x which makes it 0. Exponential, continuous everywhere, differentiable everywhere, but the question we did had a modulus in it. That's why it was not differentiable at x equal to 0. Greatest integer function, not continuous and hence not differentiable when the value of x is an integer. Keep this in mind because for MCQs you cannot waste your time checking all this with continuity and differentiability definitions. Question number 4, which of the following is right about the number of points at which the function f of x is equal to 1 by x minus greatest integer of x? My dear students, understand that this function looks like a rational function in the first place. Now I'm going to teach you about the continuity of a rational function. Rational functions are not continuous. Okay, rational functions are not continuous for the values of x. For the values of x where the denominator equals 0. If the denominator of a rational function becomes 0, it is not continuous at that value of x. What's my denominator here? What's my denominator here? It is x minus greatest integer of x equal to 0. That means x should become equal to the greatest integer of x. This happens only if x is an integer. Only greatest integer of an integer becomes the same answer. Okay, that is greatest integer of 2 is 2. Greatest integer of 1 is 1. So greatest integer of an integer is always an integer. So for how many values of x does x become equal to greatest integer of x? Already right answer coming from everybody. It is infinite number of points, because we have infinite number of integers. 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. We have infinite number of integers, which makes my denominator 0. Which makes my denominator 0. Okay? Let's move on, my dear students, to the next question. Again, f of x equal to modulus sin x. Yes, you have been taught about modulus part, but this time you are seeing something else inside the modulus called sin x. Please remember that sin x alone is always continuous. We know the graph of sine, periodic graph of sine, the wave function which goes up, down like this. It is a continuous graph, so it is a continuous function. And hence, it's also differentiable. Sin x is continuous and differentiable for all values of x. But now a new problem arises. Sin x is not alone. It is sitting inside the modulus. It is sitting inside the modulus. Yes? Very good. Answers already coming from yes, 7 of you. Very good. All the answers are right. Good students. But whenever a modulus comes, what's the idea? Whenever a modulus comes, sin x equal to 0. We have to check the value of x for which sin x becomes 0. If x is a integer multiple of pi. N should be an integer and x should be an integer multiple of pi. Option B. What is the reason? Sin 0 pi, sin 1 pi, sin 2 pi, sin 3 pi, sin minus 1 pi, minus 2 pi, every value is 0. So the modulus becomes 0 if sin x becomes 0 and sin x becomes 0 for n pi. So what would you say then? So not continuous. So it's continuous, right? Sorry, is continuous, but not differentiable at x equal to n pi. The values which makes it 0. The values which makes it 0. Option B, right answer coming from all of you. Very good. Okay, I hope it's clear. A new function introduced again to continuity part, sin x. But every function I'm introducing, I'm bringing it along with a modulus, just to tell you that modulus, continuity and differentiability is a very, very important question for MCQ. Question number 6. Do you see again a question of modulus, but this time around I've made a small change in the question. It's about addition between two functions. Remember, f comma g are continuous. Then according to the property of continuity of functions, f plus g, the addition, f minus g, the subtraction, f multiplied with g, the product, f divided by g, provided that g is not equal to 0. All these are continuous. The last one is a rational form. That's why I said provided g not equal to 0. So all these become continuous. Do you see the first one is modulus? Do you see that the first one is modulus? And we know that modulus is continuous. Do you see that the second one is mod x minus 1? And do you understand that that is also continuous? So we can say that mod x and mod x minus 1 are continuous. So f of x is continuous. Okay, so I'm going to take out option C and no other option which says it's not continuous. Okay, fine. But what about the differentiability? What about the differentiability? Mod x is equal to 0 if x equal to 0, and mod x minus 1 becomes 0 if x equal to 1. So these are the two values of x which makes my modulus functions 0. One modulus function is mod x, the other modulus function is mod x minus 1. There are two values of x which makes each of my modulus 0. So can I say that it is continuous but not, therefore not differentiable at x equal to 0 and x equal to 1? 2 points. Continuous and differentiable, wrong option A. Continuous and differentiable at only 2 points, again wrong option. Look at option D, my dear students. What does option D tell you? It is continuous all points but not differentiable at only 2 points. What are the 2 points? X equal to 0 and x equal to 1. Yes, right answer. This time only few of you said the answer. Okay, that's why this type of a question is sometimes difficult for you. Understand, addition between two functions which are continuous means both the functions are continuous, means f plus g, f minus g, f into g and f by g. For f by g, remember, g should not be 0. It's a rational form. So all these forms are also continuous. Very, very important for us. Okay, and what are the two values you can say? 0 and 1, where the modulus becomes 0. Hence at 2 points they are not differentiable. Modulus is not differentiable at the values of x, which makes it 0. Okay, moving on, students. Question number 7. This given function f of x is equal to sin x by x plus cos x if x not equal to 0, and k if x equal to 0 is continuous. Then what is the value of k? It's not a 2-mark or a 3-mark question to show them what is LHL, what is RHL. This is normally called a piecewise function. A function which has 2 or more parts is called as a piecewise function. Simply take the function with the limit of x tends to 0, sin x by x plus cos x equal to the second value, which is k. Don't waste your time trying to find LHL, RHL straight away. Can you tell me the property of limit of a function for limit x tends to 0, sin x by x? That's definitely 1. Limit of x tends to 0, sin x by x is definitely 1. So this part is 1. What about cos 0 equal to k? So 1 plus cos 0 is also 1. K is equal to 2. K is equal to 2. Option B. K is equal to 2. A straightforward question, for very easy question for 1 mark. I put this question just to tell you that you need not always check LHL, RHL for continuity. You can just take the two pieces, equate them, finished. Wherever there is an x, substitute the limit of x. That's all. Okay. Good answers? Yes. Answer 2 coming from Prapti, Hafez, Hadia, Raina, is Andil, Sana and Ebin. Good. Okay. Moving forward to the next question, number 8. Again, what is the value of k which makes the function continuous? Let's not waste our time again. Here the value of x is again approaching 0 and the first piece is sine of 1 by x. Careful with this. Equal to k. Come on, students, what happens if I try to substitute x equal to 0 there? If I try to substitute x equal to 0 here, you get sine of 1 by 0, which probably is sine of infinity. Okay, sine of infinity is normally, everybody will say not defined. Don't jump and say not defined. Okay, sine, whatever be inside sine, you can say the value of sine x always lies between -1 and 1. So it's a defined value, but we don't know what value it is. So we'll say that k is not attained. You cannot find the value of k. For what value of k is the question? I cannot tell what value of k gives me this continuity. So they're saying 8, they're saying 1, they're saying -1. So we don't know which value. So the most probable answer you can give for this is option D, none of these. It's an MCQ. The most apt answer is what you have to give. So 8, no. 1, no. -1, no. The answer is option D, none of these. Most of you would say sine infinity not defined. No, it's not a not defined value. It's a value between -1 and 1. Okay, so we cannot say which of these answer, so you have to say none of these. K could be any value from -1 to 1. So do not say which value it is, say none of these. Okay? A very similar question number 9. A very similar question, but this is a slightly different question. They are saying that this function is continuous at x equal to 0. Yes, then what is the value of this function? Let's again say, let value equal to k. Again, let us assume that the value is equal to k. That implies when the value of x approaches 0, x squared into sine of 1 by x equal to k. Yes, very similar question, but the difference between the previous question and this question is that is simply one sine of 1 by x, but this is x squared into sine of 1 by x. Yes, very good, Prapti, Fahad, Hafez, Faris, Hadia and Angeline. Yes, Sana, very good. All of your right answers coming right away. We know that if I try to put the value of x equal to 0 here, it's always a value which lies between -1 and 1. -1 to 1 is a numerical value, yes. But when I try to put the value of x equal to 0 here, it implies 0 squared into some value between -1 and 1, right? What happens if I multiply 0 to any number between -1 and 1? The answer is definitely 0. It's a simple, sensible answer. That's it. Answer should be what? 0. Option A. Many of you have already given the answer as option A, 0. But it is sometimes confusing. Sometimes it is confusing. It's one of the silliest questions they can ask you, but it's sometimes confusing. Okay, learn it. Simply sine of 1 by x and x squared into or x cube into whatever they want, let them put. It's not going to affect us. The final output is going to be the same. Okay, clear? Moving on, my dear students. Can I move on to the next question? Yes, right answer coming from all of you. Okay, good. Question number 10. The function given by f of x is equal to tan x is discontinuous. So, the function f of x is equal to tan x. But I prefer to write tan x in a rational form, which is sin x by cos x. I have written this in what form, dear students? I have written this in the rational form. And when it comes to a rational form, you always decide the continuity based on the denominator. What is the value of x which makes my denominator 0? It's cos x, and the most basic value you know about cos x to become 0 is pi by 2. Cos pi by 2. Yes? Not cos 0, not cos pi. Cos pi by 2. And the next value you would say is cos 3 pi by 2. The next value is cos 5 pi by 2. Do you see that these are all odd number multiples of pi by 2? Odd number multiples of pi by 2. That implies x is going to be an odd number. 2n plus 1 represents odd number multiples of pi by 2, where n belongs to an integer. N belongs to an integer. Clear, my dear students? What is the value of x which makes my cos x 0? Odd multiples of pi by 2. Very good, Prapti, Hadia, Hafez, yes, Nithin, Raina, Abdul and Faris. Very good. So the answer is option D. Yes, The discontinuity for tan x happens when cos x becomes 0 at odd multiples of pi by 2. And I would want you to remember, along with tan x, the similar condition will come for f of x equal to sec x as well. Discontinuity of sec x. Sec x is 1 by cos x. Again, a rational form with 1 by cos x. The same result. The same result. So they can ask you in the exam, sin x is continuous, cos x is continuous, but about tan x, it's not continuous. It's not continuous for odd multiples of pi by 2, and sec x also the same. Okay? Then I think everybody can say what are you going to do with cot x now, right? Yes? Then what are you going to do with cot x now? Cot x is going to be written as? Cot x is going to be written as the rational form cos x by, and sin x, you know where sin x is going to become 0. Already we discussed. Yes? Sin x becomes 0. So not continuous at x is equal to multiples of pi, integer multiples of pi, n pi. Remember. So what is the similar function? Like cot x, what is the similar function? Cosec x. Cosec x is 1 by sin x, which holds the same property. So which is my answer here? Option A. Option A. X is equal to n pi. Very good. Very good. Yes. Now everybody is coming into the track. Everybody is now getting the idea on how to quickly analyze the continuity and differentiability of certain functions, which can easily come for 1 mark. Okay? Moving forward, students, the function f of x is equal to x minus 1 divided by x into x squared minus 1 is discontinuous. Again, it's a rational function. Again, it's a rational function. What should you do to a rational function? Analyze the denominator. Denominator is x into x squared minus 1 equal to 0. That is x into x minus 1 into x plus 1. You can see x squared minus 1 is like a squared minus b squared, which is a minus b into a plus b equal to 0. So what are the values of x? X equal to 0, x equal to 1, x equal to negative 1. I have 3 values of x which can make my denominator 0, and I would say my answer is option C, exactly 3 points. Yes, exactly 3 points. But I have seen certain students making a mistake in this question. The mistake they usually do is this one. They would say, sir, why can I not simplify this and say this is going to be x into x minus 1 into x plus 1? And why can't I cancel this x minus 1 and x minus 1? Already I got few of you saying that as the answer. Option 2 points. 2-3 answers already came with 2 points. Why do they think like this? I asked you the denominator to become 0, right? Sir, this is also possible. I can take out x minus 1 and say 2 points of discontinuity. No. This type of discontinuity is called a removable discontinuity. What is it called, my dear students? It's called a removable discontinuity. Yes, the other two, x and x plus 1, are irremovable discontinuities. Okay, x minus 1 is a removable discontinuity, but whether it is removable or irremovable, it's still called a discontinuity, my dear students. They never asked you what is the number of irremovable discontinuities. No, they asked you what is the number of discontinuities. There are 3 points. Don't do this. Don't factorize. I hope everybody is clear. Factorization is only done for irremovable and removable discontinuities, and that usually doesn't come for you. Don't worry. Okay, fine. Moving on. The next one, again, it's a very similar question. So I'm going to quickly go through the answer. 4x minus x cube equal to 0. I can take x common out. 4 minus x squared equal to 0. The second bracket is like a squared minus b squared, which is a minus b into a plus b equal to 0. So what are my 3 points of discontinuity? X equal to 0, x equal to 2 and x equal to -2. Again, I have 3 points of discontinuity. Discontinuous at exactly 3 points. Discontinuous at exactly 3 points. Yes? Easy again? Okay? Very good. Answer C is correct for most of you. Now moving forward, look at this question. It's a very similar question. It's a very similar question. Now they want to make it continuous. If it has to become continuous, then what should be the value of f of 3? What is the meaning of that? Okay, in order to make f of x continuous, then what should, at x equal to 3, then what should be f of 3? If you go back here, if I say make this function continuous at 0, you would say, sir, if I put 0, the denominator is going to become 0. It's impossible. But I said there is a possibility to remove a discontinuity, right? Let's check. Can I remove a discontinuity here? Do you see that the function is x squared minus x minus 6 divided by x minus 3? Okay? Got it, all of you? Some of you have said the answer already. Yes, very good. Some of you already said the answers. Good. I'm going to factorize this actually. This is going to be factorized as x minus 3 into x plus 2 divided by x minus 3. It's a quadratic expression which can be factorized. I can take out x minus 3, x minus 3. Do you see that? X minus 3, which was creating a problem in the denominator, has been removed. So it's a removable discontinuity. So what's my new function? X plus 2. So if it has to be continuous, it should be only x plus 2. Then what is f of 3? 3 plus 2 equal to 5. Finished. Option C. Option C. Got it, all of you? So this is called a removable discontinuity, and I simply factorized it because it's easy for me to factorize the quadratic form rather than doing some other technique. Okay, it's easy for me to factorize this. I hope everybody is clear. Yes, very good from all of you. All of you said option C. Nobody made a mistake in the answer this time. Very good. Now let me show you an interesting question here. F of x is given to you, g of x is given to you, then which of the following can be a discontinuous function? Remember, f of x is x minus 3, and I call this as a polynomial function. What is this? It's a monomial or a polynomial function. G of x, x squared by 3 plus 1. It's again a quadratic polynomial, so it's again a polynomial function. And remember, my dear students, polynomial functions are always continuous. Polynomial functions are always continuous. So polynomial functions are always continuous. According to the property we learned before, what happens if I add two continuous functions? This is obviously continuous. What happens if I multiply two continuous functions? That's again continuous. What happens if I subtract two continuous functions? That is again continuous. But what happens if I divide, provided the denominator f of x not equal to 0? So let's see. F of x is x minus 3 not equal to 0. X cannot be 3. So if I put x equal to 3, this is discontinuous. Remember, is not continuous at x equal to 3. So which of the following can be a discontinuous function? Option D. Option D is the only function which can become discontinuous. The value of x should become 3 in that case. Very good, Prapti, Hafiz, Adil, Hadia, and Faris and Fahad. Very good. Moving forward, my dear students. Question number 16. This is a question pattern which is observed from NCERT Exemplar. So a possibility of this question to come is also there for us. What's the function here? The function is f of x is equal to modulus of x minus 3 multiplied with cos x. They are asking you about the differentiability of this function. Again, I'm telling you, don't go after LHD, RHD and that entire long process to get the differentiability. No, analyze them one by one. Please tell me about cos x first. Cos x is continuous. Yes. Cos x is differentiable definitely, because derivative of cos x is minus sin x, which is defined for all values of x. Because sin x graph we know. Yes. So this part is differentiable, no doubt. But what about the modulus part? We know that modulus is not differentiable. Not differentiable if the value of x is 3. Yes, it's not differentiable if the value of x is 3. So what is the conclusion you're going to say? Is differentiable for all real numbers minus 3. What is the meaning of that? Excluding 3. All real numbers excluding 3. Option B is your answer. R minus set 3. Right answers coming from Joel, Prapti, Abdul, Raina, Hadia, Fahad and Adil. Very good. So it's differentiable if you try to exclude 3 from the set of real numbers. Okay? I hope it's clear to everybody. Please learn this type. What should be the domain of this function so that this function becomes differentiable? And we understood it's not differentiable if x is 3. So I exclude 3. I got a differentiable function. Same type. Let's not waste time. What is the value of x which makes it 0? X is equal to 2 by 3. So what is the domain so that this becomes differentiable? R minus 2 by 3. Again, right answer C. Option C. Right answer, all of you. Learn it, because this type of a pattern is seen in NCERT Exemplar, and they do have a habit of asking few questions from NCERT Exemplar. The same pattern. Not the same question maybe, but the same pattern. So learn it. It's a very, very simple form to learn. Okay? Question number 18. This function f of x is cos of greatest integer x, where x is greater than 0, and mod x plus a if x is less than 0. And if this function exists, then what is the value of a? So we know that. Again, don't take LHL, RHL and waste your time. Cos of greatest integer x, when x approaches 0, greater than 0 means the right side of 0. Come on. This is less than 0, mod x plus a. What happens if I substitute a number which is slightly more than 0 inside the greatest integer? Greatest integer of something slightly more than 0 is still 0. In modulus, it doesn't affect it at all. It's mod 0. So this is going to be actually cos 0 equal to a. A is equal to 1. Only 2 of you gave the answer, because I believe you did not even try to answer because you saw greatest integer modulus. This is something which scares everybody of you. Don't be scared. When you're looking at the greatest integer, decide, am I trying to put a value of x which is slightly more than that integer or slightly less than that integer? If you put slightly more than 0, it is still 0. Yes, greatest integer of anything which is slightly more than 0 is still 0. But greatest integer of something which is slightly less than 0 is minus 1. So it's always the greatest integer before x. Yes, so the answer is 1. Option A, 1. Clear everybody? Yes? Try to understand why I'm stressing too much on continuity and differentiability of functions. Because the derivative part of it can be asked for 2 marks, 3 marks, 5 marks, for whatever they want they can ask. But when it comes to MCQ, you lose your marks when it comes to differentiation and differentiability and continuity of the functions. Yes? Good. Moving forward, this is one question. See, f of x is equal to 1 minus tan x by 4x minus pi. And this comes for MCQ. Normally everybody will not know how to do it, and they're saying that this function is continuous inside the interval, and I'm supposed to put the value of x as pi by 4, and I know that pi by 4 definitely belongs to this interval 0 to pi by 2. So it's continuous. So continuous means what? If I try to put the limit of x equal to pi by 4 inside this function, I should get the answer for it. Yes, and let me call that answer to be k. I'm supposed to find the value of this. Okay, k, or if you want, you can say that is f of pi by 4. Yes, trying to put the value, limit of x tends, continuity means limit of x approaches pi by 4, 1 minus tan x by 4x minus pi. But you are very unlucky. If you try to put pi by 4 here, you will definitely see a form called 0 by 0, and you have to do something to find a value and remove that discontinuity and get a value, because all the options are giving me values. Here I'm going to introduce a simple technique. It's called the L'Hospital's rule. Normally it's not taught in CBSE classes, but because it's an MCQ, I can teach it, because you're not going to show the steps. L'Hospital says that find the derivative of the numerator and derivative of the denominator separately. Don't apply quotient rule. No, do not apply quotient rule. Just find the derivative of the numerator and denominator separately. So what's the derivative of 1 minus tan x by derivative of 4x minus pi? Derivative of 1 is 0 and derivative of tan x is sec squared x. So minus sec squared x divided by derivative of 4x is 4. Now after doing the derivative, apply x is equal to pi by 4. Now apply x equal to pi by 4. What is sec of pi by 4? Cos of pi by 4 is 1 by root 2. So sec of pi by 4 is root 2. So answer is minus root 2, but the square is only for root 2 divided by 4. So it's minus 2 by 4. The answer is minus 1 by 2. Answer is minus 1 by 2. Once again, what is L'Hospital's rule, all of you? L'Hospital's rule says that by chance you're trying to do an MCQ question where you get 0 by 0 form, simply do the derivative of the numerator, simply do the derivative of the denominator separately, and then apply the limits. It's 1 mark MCQ, that's why I'm trying to use this method. Otherwise, it's a very lengthy process to evaluate this. It's called the L'Hospital's rule. Answer is option B. Yes, I still got 4 answers right from people over here. 4 other answers which are correct. Okay, but still the answer is minus 1 by 2. I hope everybody is clear with what is L'Hospital's rule. It's only done if you get a 0 by 0 form. Only useful if it's a 0 by 0 form, and in MCQ 0 by 0 form is common. Okay, and you do not know how to evaluate it. Very simple. Do this, substitute the value of x. Okay, moving forward. Question number 20. Find the differential coefficient. The differential coefficient means it's simply the derivative. Differential coefficient means what? Find the derivative. It's another way to say it. I want to find the derivative of sec of tan inverse x. You know what happens to students here? They straight away start doing the derivative, and they will say sec of x, sec x tan x into derivative of tan inverse x, and they'll keep doing like that. No, my options do not have the sec and tan. So my first priority is to get rid of that. And I know that from trigonometric identities that sec squared theta is equal to 1 plus tan squared theta. So what is sec theta? 1 plus tan squared theta under the root. Apply that condition here. So sec of tan inverse x is equal to root of sec theta 1 plus tan squared theta. Okay, 1 plus tan squared theta. Squared means it's whole squared. Now do you see that tan and tan inverse, yes, goes, and you can see it's root of 1 plus x squared. Get the derivative of this. Do not start the derivative right away. because my options are talking about the derivative forms only in terms of x. Then you, after doing the derivative, doing this may be complicated, but do it in the beginning. Get rid of sec and tan inverse. So the idea is, what is the derivative of root 1 plus x squared? Derivative of root 1 plus x squared, it's 1 by 2 root 1 plus x squared, and the derivative 1 plus x squared is 2x. Get rid of 2 and 2, your answer is x by root of 1 plus x squared. X by root of 1 plus x squared, option A. X by root of 1 plus x squared. Right answer coming from Fahad, Prapti, Hafiz and Nitin. Okay, it's a very, very important question. Please try to understand what's happening here. I'm not trying to do the derivative right away. I'm reducing that inverse form into a simple x term and then doing it. Okay, moving on, my dear students. Question number 21. Y is given to you, find dy by dx if x is equal to pi by 4. So y is equal to log square root of tan x. Here right away derivative. Derivative of log x, 1 by x, into the derivative of root tan x. What is the derivative of root tan x? 1 by 2 root tan x into the derivative of tan x. It's just the chain rule I'm applying here. Those who are very good in this, you can do it in one step. I'm doing all these steps for students who have not yet cleared what's chain rule. Okay, first I do the derivative of log function 1 by x, then I do the derivative of root function 1 by 2 root x, and then I do the derivative of tan function, which is going to be sec squared x. So sec squared x divided by 2 into root tan x is tan x. X is equal to pi by 4. So we already know sec pi by 4 is root 2. Root 2 squared is 2 divided by 2 into tan pi by 4 is 1. So answer for this is 1. Option B. Option B. Answer is 1. Yes. The number of answers coming now is getting reduced and reduced simply because you are not confident. You are not confident. Please, you have to try to give answers, all of you, because these are all simple questions. You just have to do the derivative and substitute the value of x. Okay? Moving forward, y is equal to root of sin x plus y. Y is equal to square root of sin x plus y. Before starting to answer this question, the actual form of this expression is not this. The actual form is this one. It's actually looking like this. Root of sin x plus root of sin x plus root of sin x plus goes up to infinity. So it's an infinite expression, though everything is under the square root. But do you see that this whole thing after the first sin x, because it's going to infinity, can be called as y? This whole thing can be called as y. So I just wrote this expression like this. So in the exam, if it comes in this form also, learn how to do it. Okay, so I just modified it and I wrote it like this. Then what is going to be y squared? Y squared is equal to sin x plus y, and they're asking you to find what is dy by dx. So what's the derivative of y squared? 2y into dy by dx equal to cos x plus dy by dx. Bring dy by dx to the left side. 2y into dy by dx minus dy by dx equal to cos x. So dy by dx common out, you get 2y minus 1 equal to cos x. Final answer, dy by dx equal to cos x divided by 2y minus 1. I squared it to avoid the confusion that is going to be created by the derivative of root. Okay? It's a very good trick you can apply. Whenever your function looks like a square root, just square it. Cos x by 2y minus 1. Option A. Yes, right answer. Prapti, Hafiz, Sana, Nitin, Abin, Hadia and Abdul. Okay, good. Moving forward. Question number 23. What is the derivative of tan x with respect to sin x? It's a very common question. This is a simple question. I'm not expecting this, but I have another question coming up later. Just to explain that, I'm giving you this question. Tan x with respect to sin x. Don't waste your time too much. It's simply what? Derivative of tan x divided by the derivative of sin x. Don't waste your time. Okay? When a function with respect to another, simply do derivative of the first function divided by the derivative of the second function. Derivative of tan x, sec squared x. Derivative of sin x, cos x. The reciprocal of cos x is sec x. So sec squared x into sec x, sec cube x. Option D. Right answer Hanan, Fahad, Prapti and Faris. It's sec cube x. Once again, when you're derivating a function with respect to another function, don't call u, v and all. It's MCQ. Derivative of the first divided by the derivative of the second. Okay? Question number 24. Do you see it's an infinite series coming up? Yes. And I already taught you how to handle an infinite series. Y plus e raised to y plus, and it is going up to infinity. So can I call everything after the first y as the same question called x? So this part of the function is going to be called as x. That part of the function is going to be called as x. So we're going to write it as x is equal to e raised to y plus x. X is equal to e raised to y plus x. Don't try to differentiate like this. Okay? Apply log. When you apply log, log x is equal to y plus x. Or you just don't think applying log, invert e. If you invert this e to the left side, it becomes log. The inversion of e is log. So log x is equal to y plus x. Then find the derivative. Now find the derivative, all of you. What is the derivative of log x? 1 by x. What is the derivative of y plus x? dy by dx plus 1. So dy by dx is equal to 1 by x minus 1 LCM 1 minus x by x. 1 minus x by x. Option C. Very good. Hanan, Nitin, Abdul, Hafiz, Fahad, Abin, Sana, Hadia. Yes. Good answers, all of you. Very good. Question number 25. F of x is x raised to n. Then find the value of f of 1 minus f dash 1 by 1 factorial plus f double dash 1 by 2 factorial and so on. Yes. So what is f of x? X raised to n. Then what is f dash of x? N x raised to n minus 1. Then what is the double derivative of f of x? N multiplied with n minus 1 into x raised to n minus 2. Yes. Now I will stop here because I am not interested in any more derivatives. I will tell you why. Because they are asking you to find with respect to the value of x equal to 1. Then what is f of 1? It's 1 raised to n, which is 1, no doubt. What is f dash of 1? N, yes, into 1 raised to 1 minus 1. The answer is n. Okay? So, once again, in the value of f of 1, f dash of 1. Okay? Now, what is f double dash of 1? It's going to be n into n minus 1 into 1. Okay? raised to n minus 2, which power of 1 is not going to affect us. It's going to be n into n minus 1. If I keep going like this, I can write an expression here, all of you. F of 1 is 1, because 1 raised to n is 1, minus f dash of 1 is n by 1 factorial, plus f double dash is n into n minus 1 divided by 2 factorial. And if I keep going like this, it's going to be n into n minus 1 into n minus 2 by 3 factorial. This is actually an expansion of a special term called 1 minus 1. You did not learn this in your 11th standard. It's the expansion of a binomial form called 1 minus 1 raised to n. Okay? Please learn, all of you. I'm going to give you two forms right now. One is with 1 minus plus minus like that. The second form is going to be 1 plus 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 like that. If everything is negative, so everything is positive, it is going to be 1 plus 1 raised to n. And if it's alternate plus and minus, it is 1 minus 1 raised to n. Learn the form, my dear students. Learn the form, my dear students. If you have alternate plus and minus sign for such an expansion, you are going to get 1 minus 1 raised to n. And if you have all positive signs, it's going to be 1 plus 1 raised to n. 1 minus 1 raised to n, no doubt. 0 raised to n. This series is always going to be 0. If it was 1 plus 1, you would have said 2 raised to n. So the only change that can happen in the question is all positive or alternate plus and minus. Alternate plus and minus. Keep in mind, all of you. Okay? I hope everybody is clear. Okay? Can I move forward now? Question number 26. Please, I want everybody to mark this question, very important. You are going to make a very, very silly mistake in this, because you have been taught the shortcut about continuity and differentiability of modulus functions. X is polynomial, hence continuous and differentiable. Modulus x is mod function, so it's continuous, no doubt, and you would say it's not differentiable at x equal to 0, sir. So your answer would be option B, because option B excludes 0. See, minus infinity up to 0, excluding 0, union 0 to infinity, excluding 0. So the only option which, so you will tick option B. It's a wrong answer. According to shortcut, it's a wrong answer. Please, the reason for this is because modulus x is being multiplied to a polynomial function, the complete story changes. We have learned that a modulus x is either a negative x when x is less than 0, or a positive x if x is greater than or equal to 0. So I'm going to write it as minus x squared when x is less than 0 and plus x squared if x is greater than or equal to 0. So this is actually the function f of x. This is actually the function f of x. Now we're going to check the differentiability of this. I want everybody to take the derivative. What is the derivative of f of x? Don't check LHD, RHD, just check the derivative. Minus 2x and plus 2x, but you're so happy to have the value of x equal to 0. We are checking what's happening at 0. When I put x equal to 0, this is going to be 0 for x less than 0 and 0 for x greater than or equal to 0. Do you see that the left derivative is also 0? The right derivative is also 0. I'm not using the definition of derivatives. It's a simple function. I'm simply taking the derivative LHD equal to RHD. So can I say it is differentiable at x equal to 0. So when you're multiplying a polynomial function with a modulus function, don't conclude that it's going to be not differentiable when the modulus value becomes 0. No. A slight modification. Please, that's why it's a very important question. So hence my answer is option A. All of you mark the answer. It's continuous and differentiable for all values of x, continuous and differentiable for all values of x. Okay, I think we have time to do one more question. This one, I have x cos y plus y cos x is equal to pi, and they've given me that the value of x is equal to 0. Okay, the value of x is 0. If x equal to 0, x cos y plus y cos x equal to pi implies 0 plus y cos 0 equal to pi. So y is equal to pi. If x is 0, y is pi. Now I'm supposed to find the derivative and put these values. So what's the derivative of x cos y plus y cos x equal to pi? Okay, the derivative is inclusive of pi, my dear students. The derivative is inclusive of derivative of pi also. What's the derivative of x cos y? 1 cos y plus x into minus sin y plus y dash minus sin y into dy by dx. Okay, minus sin y into dy by dx. Y dash, which is derivative, let me call it as y dash itself, easy for us. Y dash into cos x plus y into minus sin x. I'm just using the product rule, equal to 0. Substitute the values of x and y. This is cos pi, x is 0, second term is 0. Y dash into cos pi, and this term is also 0, equal to 0. Cos pi is minus 1, y dash into minus 1 equal to 0. So minus y dash equal to 1. So I'm getting the answer for y dash is equal to minus 1. Just check, y dash is equal to, supposed to get 1, x 1 into cos y plus x into minus sin y plus y dash into cos x plus y into minus sin x equal to 0. Cos pi 0, y dash cos pi, which is minus 1, cos pi is minus 1, answer should be minus 1, but we are not getting the answer as supposed to come as 1. Just checking the expression once again, x cos y plus y cos x, 1 cos y plus y cos x, so 1 cos y plus x into minus sin y, y dash, plus y dash cos x plus y into minus sin x. It's correct. Just putting the value of x as 0. So cos pi plus 0. Answer is minus 1. I'm just supposed to change the option D then. Answer is supposed to be minus 1. Okay. So that's enough for today. Okay. That's enough for today, all of you. And oh, I'm sorry. It's plus 1 itself. This is the mistake. This was 0 here. So this was supposed to be plus 1. Okay, thank you. So this is 1. Sorry, answer is plus 1 itself. Okay, so that's enough for today. So we have done a lot of questions based on continuity and differentiability. I hope everybody is clear with this topic. Yes, and everybody please go through the continuity and differentiability part more for the MCQs. Okay, and that's enough for today. Signing off from you. We'll come back with another session very soon. Thank you and have a very nice day, my dear students.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.